Okay, let's begin with 7.2. Share my screen. Okay. Okay, I think we're good. I don't have controls now. Okay, let's go back out here. There we go. Now I have controls. Okay, so 7.2 is on trigonometric integrals. Okay, and last time we kind of worked with some of these trigonometric integrals. Um, and we were able to do sine squared based on integration by parts. Okay, and so we're going to kind of expand what we're going to be working with in terms of powers of sines and cosines and tangents and secants. So let's set up some rules for sine and cosine. For the integral of sine to the nth power of x times the cosine the nth power of x, okay, dx. So we have an expression with powers of sines and powers of cosines. Okay, we have four rules. If the power of cosine is on, if the power of cosine is odd, okay, break off a cosine factor and then change all the cosines to sines using 1 minus sine squared x. And use 1 minus sine squared x for the remaining cosines. Okay, so we would break off a cosine and then change everything else to sines. And so I'd end up with a nice u du substitution. Okay. Sorry, 1 second. I need to see if my video is on. My video wasn't on. Okay, let me go back. Okay, there we go. Okay, number 2. If the power of cosine is odd, sorry, not odd. If the power of a sine is odd, okay, break off a sine factor, which would reduce the sine to an even, and then use 1 minus cosine squared x for the remaining sines. So it's just the opposite of what we did in number 1. Okay. Okay, number 3. Okay, if the power of sine or cosine are both odd, if the powers of sine and cosine are both odd, then you can choose. You can choose to turn them into sines. You can choose to turn them into cosines. Either one or two can be used. One or two can be used. You have a choice. Right? Okay, and number 4, if the power of sine and cosine are both even, this one's the hardest one. If the power of cosine and sine are both even, then we have to use a half angle identity. Use a half angle identity. Such as, oops. We have sine squared of x is equal to 1/2 times 1 minus cosine 2x. Cosine squared x is equal to 1/2 times 1 plus cosine 2x. And sine 2x is equal to 2 times the sine of x cosine x. Okay, so we use a trig identity to help us if they're even. Okay. Okay, let's do an example. Number 1. Okay, number 1 says evaluate the integral of cosine cubed x dx. Okay, so here cosine is even. So what do I want to do? Cosine is even. I'm sorry, cosine is odd. If cosine is odd, break off a cosine and use 1 minus sine squared for the remaining cosines. Okay. So what does it mean to break off? Well, I'm just going to factor off a cosine here. This becomes cosine squared x cosine x dx. And then it says turn the remaining cosines into sines by using the fact that I have a Pythagorean identity, sine squared x plus cosine x equals 1, right? So if I subtract sine squared x from both sides, I get cosine squared x equals 1 minus sine squared x. So I'm going to change this to 1 minus sine squared x times cosine x dx. Okay. And now I can use some elementary integration techniques to help me out. I'm going to distribute the cosines. When I get cosine x minus sine squared x cosine x dx. Right? And so I'm not going to actually break this up into 2 different integrals because one I can just integrate directly and the other I'm going to have to do a u sub on. So I'm going to integrate this cosine x dx minus the integral of sine squared x cosine x dx. Okay, and what's the integral of cosine?
Sine x.
Sine, yeah, sine. So this is just sine x. Okay, I could put a plus c here, but that would mean that I would end up with 2 plus c's. So, I mean, the c's are just going to end up combining. If you add a constant to a constant, you're gonna get a constant. I'll put it there for right now, but just know that that's gonna combine with the other c from the other integral, and so we're only gonna get one c. Okay, so the next integral here is basically u is gonna be sine x. Okay, du is cosine x dx. So here's my du. And my u is just u squared. So this is going to be the integral of u squared du. Oh, okay. We have sine x plus c minus the integral of u squared du. But what is the integral of u squared du?
U to the cube.
Yeah, u
Yes.
cubed over 3, or 1/3 u cubed, right? And then I could put a plus c there as well if I want to. Okay, sine x plus c minus the integral of u cubed, or minus u cubed over 3. But what was u?
Sine x.
Yeah, it was sine x. So this is going to be minus 1/3 sine cubed x plus c, and these two c's would combine into one c. And so we get sine x minus 1/3 sine cubed x plus c. Okay.
Professor, why doesn't the negative go to the C?
Oh, it can. If you really want to, it can. But what if c was already a negative number? Wouldn't it make it positive? So it really doesn't matter. It wouldn't be 0.
Okay.
It would still be c.
Okay, thank you.
Because c could be like 5 or 7 or negative 100. This c, I call this c1, and this c maybe I'll call c2. And we could call this c3, in which c1 minus c2 is equal to c3. Does that make sense?
Yes, sir.
Okay. You'll do a lot more of that if you have to take Calc 4, which is differential equations. We do have to reconcile the c's. In this class, you don't have to reconcile the c's. You can just be like, okay, there's going to be a constant at the very end. Okay. But it's good to see at least once. Pun intended. Okay, number 2. Y'all get that, right? See at least once. C as in constant. Forget it. If you have to explain it loses its value. Okay, number 2. Find the integral of sine to the 5th x cosine squared x dx. Okay, so here the sign is odd. And if sine is odd, I want to break off a sign. So this is going to become sine to the 5th x, or sorry, sine to the 4th x cosine squared x times sine dx. Okay, so what we did was we broke off a sign. Because again, this is going to end up being my du. Okay, which means my u needs to be in terms of cosine. And so how can I turn this sine to the 4th into cosines? Well, I'm going to be a little sneaky. I'm going to call this sine squared x to the squared. Cosine squared x, sine x, I forgot an x, sine x dx, right? But what did we say sine squared x was? Wasn't that 1 minus cosine squared x? Right? From that Pythagorean identity. Cosine squared plus sine squared equals 1. Therefore, sine squared had to be 1 minus cosine squared. But keep in mind that that's squared. That thing is squared. So then it's cosine squared x times sine x dx. Oh, okay. So now I can multiply this out. This is going to become 1 squared minus 2 cosine squared x plus cosine to the 4th x, all of that times cosine squared x times sine x dx. Right? And so if I distribute the cosine squared, I get cosine squared x minus 2 cosine to the 4th x plus cosine to the 6th x, put that in brackets, times the sine x dx. And now I'm ready to do my u du substitution. I'm going to let u be cosine x, which tells me that du is negative sine x dx. Okay, and so that would mean that negative du is equal to sine x dx. So now what we have is we have u squared minus 2 u to the 4th plus u to the 6th times negative du. And I could just pull that negative sign outside if I really wanted to. Okay, maybe I'll put the negative out there. And then I'm just going to integrate term by term. This is going to be u cubed over 3 minus 2/5 u to the 5th plus u to the 6th over 6. Okay, plus c. And there's a negative out there. Okay. And then I just plug in what u was. Well, what was u? Yeah, u was cosine x there, right? That's what my u was. So this is going to become, I could distribute the negative, negative 1/3 cosine cubed x.
Professor, isn't the last u supposed to be used to the 7th?
Yes, thank you. Thank you very much. Okay, that's going too fast, but yes, perfect, thank you. U to the 7th over 7. Okay, so this is negative 1/3 cosine cubed x plus 2/5 cosine to the 5th x minus 1/7 cosine to the 7th x plus c. And that's it. And we're done. Okay, let's try another one. Okay, let's try this one. Okay, 3 integral of sine squared x dx. Okay, so the integral of sine squared x dx. Okay, so this is to the 2nd power. It's even. Sine is even here. And so what I have to do is I have to do a half angle identity. I have to change this into 1/2 times 1 minus cosine 2x dx. I believe that's my half angle identity that we wrote above.
Yes, sir.
Yes, it is. Okay. And so we're going to integrate this guy. And what I'm going to do is I'm going to distribute the 1/2. Make it a little easier on myself. 1/2 minus 1/2 cosine 2x dx Okay, I mean, I could have pulled the 1/2 out in front. Maybe I'll do that instead. I don't know. It really depends on what is or is not easier. Maybe I'll do that to just get rid of that 1/2 right away. Okay, so now I need to break this up into two separate integrals. This is going to be 1/2 times the integral of 1 dx, okay, minus the integral of cosine 2x dx. Okay. Well, I know what the integral of 1 is. What's the integral of 1?
X.
X, very good. So this is just x. Okay, and then minus, okay, the integral of cosine 2x. This one I'm going to have to do a u sub on. So u is equal to 2x. Du is equal to
2 dx.
2 dx. Yep, exactly. Divide by 2, and we get du over 2. Right? So this is going to be the integral of cosine u times du over 2, okay, minus the x minus that. And then we have the 1/2 on the outside. Okay. And so the integral of cosine is sine, right? And I could pull that 1/2, that du over 2, 1/2 on the out in front of the integral if I really wanted to. Maybe I'll write it like that. Minus 1/2 times the integral of cosine u du. Okay, and so the integral of cosine u is just sine u. So this is going to be 1/2 times x minus 1/2 times the sine of u, right? And then that's all, basically plus c. Okay, but what was u? U was 2x. So this becomes 1/2 times x minus 1/2 sine 2x plus c. Okay, and then we get to multiply by the 1/2, we get 1/2 x minus 1/4 sine 2x plus c, because c over 2 is still a c. Okay. Okay. Let's look at tangents now. Tangents and secants. For the integral of tangent to the nth degree of x, secant to the nth degree, that is dx. Okay, we have a couple of rules for this one. One, okay, if secant is even, factor out secant squared, secant squared x, and convert the remaining Okay, the remaining tangents to secants. Is that right? No, remaining secants to tangents, I'm sorry, backwards. The remaining secants to tangents. Okay, and why would we do this? Why would we want everything tangent? Because what's the derivative of tangent? Anybody remember?
Secant square.
Yeah, secant squared. So this would be my u, and that would be my du. Okay, so I would be setting up a u du substitution in which u is my tangent. I would want to turn everything into tangents, and then my du would be secant squared.
So Professor, if it's just secant squared x, do you just factor it out and continue on?
That's a great question. Okay, if it's just secant squared x, then what's the integral of secant squared?
This is tangent.
It's tangent. It's just that process in reverse. Right? Instead of going forwards in this process, we integrate secant squared x, and that would just be tangent x plus c. Right?
Okay.
Okay. Number two, if tangent is odd, okay, factor out a secant x tangent x, okay, and convert the remaining tangents to secants. Okay, once again, why? Why would we do this? Because what is the derivative of secant? Well, isn't that just secant x tangent x? Right, so once again, we're setting up a u du. Now, how do we convert these? How would we be able to convert secants to tangents and tangents to secants? Well, yeah, I have a very handy formula to do that. 1 plus tangent squared x is equal to secant squared x. So if we have tangents squared, tangent squareds, we can change them into secant squared minus 1. If we have secant squareds, we can change them into tangent squareds. Okay, using these formulas. Okay, does that make sense? Okay. Okay, for other cases, number 3, for the other cases of these, use integration by parts. Okay. So by parts. Okay. However, I'll put a little star here. Okay. What if tangent is odd, but there are no other secants? Okay, it says factor out a secant tangent. What if there are no secants? For example, what is the integral? I'll just make this number 4 here. What is the integral of tangent of x? What is the integral of tangent of x dx? Okay,
Negative ln cosine plus c.
okay, why? How did you get that? Did you look at the formula sheet?
No, I just remember that.
Oh, you did. Oh, very good. Very good. Okay, so how do we get this? Well, sometimes, okay, we want to change things into sines and cosines. And I remember that tangent is the integral of sine x over cosine x, right? Okay. Good. Okay. So how are we gonna do this? Well, what if I do a u/du substitution? What if I say that u is equal to cosine x? Then what's du? Du is negative sine x dx, right? Okay. So this would be equal to, okay, the integral of negative 1 over u du. Okay. Okay, and so this is negative times the integral of 1 over u du. And what is the integral of 1 over u? What's the definition of the integral of 1 over u?
ln.
Yeah, it's natural log. So this is negative natural log of u plus c, right? But what is u? It sounds like bad English. What is u? I is cosine x. That's what I is. Okay, negative natural log of cosine x plus c. But now I'm going to use a property of logs, in that this is really the natural log of cosine x to the negative first power plus c, which is really the natural log of 1 over cosine x plus c, which is really the natural log of secant x. Absolute value. I forgot my absolute values. My bad. Okay, natural log of absolute value secant x plus c. So what is the integral of tangent x? It's the natural log of secant x plus c. Okay, so sometimes we need to turn them into sines and cosines. Okay, so for other cases, use integration by parts or change everything to sines and cosines. Okay.
Excuse me, Professor.
Yeah.
Could you roll up for the rule number 2?
Rule number 2, sure.
Yeah. It's if tangent or secant is odd.
If tangent is odd, factor out a secant tangent. And then convert the remaining tangents to secants. Yeah, using this guy right here. Okay. Yeah, that's correct.
If tangent is odd.
Yeah, tangent's odd. factor out a secant tangent. And that'll give
Yes.
you,
Not
that'll,
secant?
yeah, that'll leave you with a even tangent. And then you convert all the tangents to secants. Okay, let's do an example and hopefully you'll be able to see, oops. Hopefully you'll be able to see that a little bit better. So. Yeah, let's do number 5. So here tangent is odd. So tangent to the 5th of theta times secant to the 7th of theta d theta. Here tangent is odd, right? And so we want to do what? We want to pull out a tangent secant. So that's going to leave a tangent to the 4th theta, secant to the 6th theta, and then a secant theta, tangent theta d theta. Okay, does that make sense?
Yes.
So now what do I want to do? I want to change all of the tangents to secants. So what do I know? I know that tangent squared theta is equal to secant squared theta minus 1, right? So I'm going to plug that in here for tangent squared, but this is tangent to the 4th. So that's tangent squared squared, which is going to be secant squared minus 1 squared. And so we get secant squared theta minus 1 quantity squared, secant to the 6th theta, secant theta, tangent theta, d theta. Okay. So far, so good? Okay, so what happens when I multiply this out? I get secant to the 4th of theta minus 2 secant squared theta plus 1 times secant to the 6th theta times my secant theta, tangent theta, d theta. Okay. So now I'm going to distribute my secant to the 6th power, and I get secant to the 10th, okay, secant to the 10th of theta, minus 2 secant to the 8th of theta, plus secant to the 6th of theta, times secant theta, tangent theta, d theta. Okay. Okay, so now what's my u? What's my u? I'll put parentheses here.
Secant
What-
theta.
Yeah, secant theta, very good, thank you. Okay, what's my du?
Secant theta, tangent theta.
Exactly, secant theta, tangent theta. Okay, so here's my du right here. Okay, so this is going to become u to the 10th minus 2u to the 8th plus 6u plus u to the 6th. Okay, du. Okay, that's a pretty easy integral. That's just going to end up being 1/11th u to the 11th minus 2/9 u to the 9th plus 1/7 u to the 7th plus c. But what was u? U was secant theta. So this is 1/11th secant to the 11th theta minus 2/9 secant to the 9th theta plus 1/7 secant to the 7th theta plus c. Always plus c. Always look at it. Okay. Okay, let's take it one where tangent is even and secant is even. What happens when tangent is even and secant is even? Let's do number 6. Tangent is going to be to the 6th power. And secant is to the 4th power. What do we do here?
For rule 1. Against even.
Remove 1?
Yeah.
No, she said rule number.
Oh, rule number 1. Okay, well, what's rule number 1? Says if secant is even, factor out a secant squared and convert remaining secants to tangents, right? So, okay, so let's factor out a secant squared. So that's secant squared x dx. And then it says convert the remaining secants to tangents. Well, what is secant squared x? Isn't it 1 plus tangent squared x? Is that right? I think so.
Yes.
Okay. And then this is secant squared x dx. Okay. Good. Okay, distribute tangent to the 6x. That's tangent to the 6th power x plus tangent to the 8th power x secant squared x dx. Okay. Okay, and so again, this is a pretty easy du substitution. I have my du here. The u is tangent x. The du is secant squared x dx. Okay, and so we just have the integral of u to the 6th plus u to the 8th. Make sure I'm doing this right. I don't want to screw it up. Looks good. Perfect. Okay, du. So this is 1/7 u to the 7th plus 1/9 u to the 9th plus c. And what was u? U was tangent x, right? So this is going to be, I'll rewrite it as 1/9 tangent to the 9th of x plus 1/7 tangent to the 7th x plus c. Always plus. Okay, you ready for a couple more that are a little spicier? Okay, little spicier. Let's try 2 more. Let's just do 2 more that are a little bit spicier. Okay, so what are we on? We're on number 6. Let's do number 7 and number 8. Okay, number 7. What's the integral of secant cubed x dx? What's the integral of secant cubed x dx? Well, is tangent odd? Nope, there's no tangent. Is
Can you
sec-
break it up
yeah, you could break it up. What do you want to break it up into?
into secant square x and then a secant x?
Okay, sounds good. Is that con? Who's that?
Samantha.
Oh, okay. Secant squared x and secant x dx. Okay, so let's break that up. We'll break that up there. Okay. So now what do we want to do?
Use the first rule. For factor the secant square x. Oh wait.
Yeah.
Use identity for secant square.
Okay, and what would we get?
So 1 plus tangent square.
Okay, but what's the derivative of tangent?
Tangent is secant square. Oh no, that's wrong. Yeah, we
Use the
cannot do.
product rule
The
that
product?
U and V and dV.
Yeah, you mean integration by parts?
Yes.
Yeah, we're gonna revisit. Let's put a pin in this one. And we're gonna revisit this in a second. Okay? So we're gonna say this is let's try some integration by parts. But I'm actually gonna do number 8 first. Okay, we'll come back to this one. Okay, so maybe leave yourself like half a page of paper. Okay, and we'll come back to this. I need to do this one first because I don't know what the integral of secant is. Okay, I do know what the integral of tangent is. What's the integral of tangent? Did we saw that one, right? What was the integral of tangent? I just proved it.
Ln cosine.
No, not cosine.
Secant.
X, right? So that's,
Oh yeah.
but what's the integral of secant? What's the integral of secant? Yeah, that one's a little bit harder in that we have to do some kind of algebraic sleight of hand. So let's look at secant x. Okay, now dx. This is a dx. I always forget my dx. Okay, we'll put that because in order to do the problem number 7, I have to know what the integral of secant x is. I end up with an integral of secant x, and I got to figure out what the heck that is. Right? Okay, so the integral of secant x dx, I have to create what's called a magic 1. Okay, I need a magic 1. And this comes to us from people who did mathematics all their lives and played around with this stuff and spent hundreds of hours on this. Hundreds of hours we don't have in our daily lives right now. But what they discovered was if I multiply by my magic 1 here, I can then integrate. And what's my magic 1? What's the magic sauce here? The magic 1 is secant x plus tangent x on top and bottom. Okay, if I multiply both top and bottom by secant x plus tangent x, that doesn't change anything, right? All I did was multiply by 1, but it's a magic 1. Okay, this is my magic one. Because what does this allow me to do? It actually allows me to integrate. Okay, so we kind of need to develop this identity, you know, these two identities in order to do the previous problem. Okay, I need to know this identity and I need to know this identity, whatever this comes out to be. Okay, so using this magic one, I'm going to put this over one, and then I'm going to distribute. And I get the integral of secant squared x plus secant x tangent x. Wasn't isn't that nice? Why is that so nice? All over secant x tangent x. Okay, or I might write it as tangent x plus secant x. Either way is fine. What's so special or what's so nice about this? Can anybody see why that magic one made things so incredibly nice? What's the
You can do the U sub.
yeah, you can do a U sub. What's the derivative of tangent?
Secant square.
Secant squared. Isn't the derivative of tangent secant squared? And what's the derivative of secant?
Secant and tangent.
Secant tangent. Isn't the derivative on top of the original expression? Isn't this just 1 over u du? Yeah. It's pretty amazing. So it's a u du substitution. If I let u equal tangent x plus secant x, then du is equal to secant squared x plus secant x tangent x dx. So this just becomes the integral of du over u, which is what? Natural log of u plus c, which is the natural log of u, which was tangent x plus secant x plus c. Okay, so that is nice. Now I know what the integral of secant is. The integral of secant is, I'm going to put it the secant first, just because that's the way I've memorized it, is the natural log of secant x plus tangent x plus c. Okay? Does that make sense? Stop, go away. Okay, so now I know what the integral of secant is. Now I can use integration by parts on the previous problem. So let's do that. Let's do integration by parts. Okay, keeping in mind that I do know what the integral of secant is now. So, okay, so this didn't work. I'm going to cross that off. That didn't work. But I'm going to do a u dv. Okay, I'm going to do an integration by parts here. Okay, what should I let my u be? And what should I let my dv be to make things easy? Well, what's the derivative of secant squared? That's a chain rule. That's kind of not nice. What's the integral of secant squared? What's the integral of secant squared?
Tangent.
What's the derivative of secant?
Secant and tangent.
Yeah, secant tangent. Okay, so I'm going to use that as my integration by parts. I'm going to get secant x tangent x minus the integral of secant x tangent squared x dx. Okay, okay, nice, nice, nice. So now what I'm gonna do is I'm going to turn that tangent squared into a secant squared. So this is what, secant squared x minus 1? Stop. Okay, integral of secant x dx. Secant x tangent x minus that, right? Okay. Okay, and what are we looking for? We're looking for, the original was the integral of secant cubed x dx. Okay, nice, nice, nice. So let me distribute. And I get the integral of secant cubed x dx is equal to secant x tangent x minus the integral of secant cubed x plus, if I distribute the negative as well, okay, from here, distribute the negative, plus secant x, okay, dx. And I'm actually going to turn these into two different integrals. Okay, nice, nice, nice. And we're so close to being done. How? How are we so close to being done? Well, I have this secant cubed x, and so I'm going to add that to both sides. And that gives me 2 secant cubed x dx's integral is equal to, that goes away, secant x tangent x plus the integral of secant x. But what was the integral of secant x? We just proved that. Natural log of secant x plus tangent x plus c. So now all I have to do is divide by 2. And my result, come on, almost done. Okay, is the integral of secant cubed x dx is equal to, okay, 1/2 secant x tangent x plus 1/2 natural log. But I could turn that 1/2 natural log into a square root. So this is going to be the natural log of the square root of secant x plus tangent x plus c. And that's my answer. Okay. Ta-da. Yikes. Okay, and that's it. That's it for 7.2. Okay, so we had to do kind of find our magic one and do that as well. Let me turn off my recording.